From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 232, recorded live Thursday, September 9th, 2010. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks with Colin Miller about the .NET Micro Framework.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes. Today I've got Colin Miller, the product unit manager for the .NET Micro Framework, a tiny framework. Thank you, Colin, for taking a second to chat with me today.
Thank you.
I'm looking at my Spot watch. I've got a Spot watch. Spot was a smart personal object technology, and I remember that this thing came out. It came out in 2004, and I loved this thing. It was tiny, and they always told me that I could write .NET code on this. I could write C# and it would talk. Now, I never got around to writing C# code, but did this watch really run .NET?
It did, actually. Unfortunately, you probably would have been disappointed to try and write C# code, because one thing we didn't do at the time was actually expose the ability to download your own applications on it. So, but it did support downloading assemblies, all of which were written in C#. One of the things in looking at creating that watch was we were looking, as you can tell from the name, we were looking at a very broad idea of smart personal objects, all sorts of things becoming smarter in your environment. And we were looking for a platform that we thought we would want, frankly, we want to be working in these small devices, and not finding one. We ended up creating one, and by taking the idea and the CLR model and re-implementing it specifically for these very small devices, and then actually extending it quite a bit for things that are specific requirements of embedded devices. So exposing the underlying hardware, interfaces, GPIO, things like that, and power management, things that frankly aren't very interesting on a desktop .NET application.
Was that an unusual idea? I mean, were you there in those first meetings where they were like, "Yeah, let's do it in C," and you're like, "No, let's just use .NET"?
Yeah, we actually tried to do it in C to start with, and we looked at some platforms that were available in research and commercially, and had some failures right off the bat. And the embedded development's always been a very specialized set of skills, and which, frankly, we didn't have a lot of inside Microsoft. We did have a lot of .NET developers, and so we could see that if we were going to develop applications, it was going to be much easier to get the skills to do that if we had a platform that would allow us to use the bulk of the development skills that both Microsoft has, but also, frankly, the general industry has. And the idea certainly was that we would have a platform that would be open to a lot of variations in applications. So finding something where we had a much higher productivity than the current model of embedded application development was key to the whole idea. And this happened sort of concurrently with some things happening in hardware that made all this possible. That up until not too many years ago, about that same time, almost all applications were written on little 8-bit processors, and then suddenly the 32-bit processors came down in power consumption and price. So it was economically feasible to make these devices in a language that is the same, and a set of tools that are the same ones you use on a desktop, and to change the way embedded development is done, so that it's not done again by specialized skills and using specialized tools, but by using the same tools that you have using for your other applications. One of the things that I think makes it really interesting is that we're seeing more and more connected devices coming out. There's actually estimations that there are as many devices at this point talking to each other over the internet as there are people, and the expectation that that's going to be many times as many devices as people in the near future. So these devices are now becoming part of the ecosystem, like we sort of saw potentially happening back in 2004. And as they happen, as they start to become parts of larger solutions rather than isolated embedded devices, it becomes more and more interesting for the developers to be able to, for .NET developers to be able to work in these on these small devices as well. At the PDC not too long ago, Professional Developers Conference, I had one guy extremely excited about the micro framework because his company had just turned down a job which included required that they work on a device, and now he realized that they didn't have to do that anymore. That doesn't mean that this is the platform for all embedded development, but for a large number of embedded applications, the kind of productivity that you get from development makes it feasible to generate applications really quickly that may not have the same real time or very specialized requirements that others do.
Mm-hmm, mm-hmm. When I think 32-bit processor, I think about 386s and 46s, and now you're saying that they're connected, and I've seen a lot of these boards have USB and have different plugs that I'm used to seeing. Are these tiny 386s and 46s that we're able to buy for a couple $, now, or is it something else?
Well, these are mostly like ARM processors, SH2 processors from Anesys, Cortex processors. Not too many 386s and 486s. These are mostly like the ARM7 size processors.
So these are all RISC processors?
Yeah, they're almost all RISC processors. And they're up in the watches were done on a 27 megahertz processor. The current ones are in the 70 megahertz range frequently.
Really? But they're equivalent in power. I mean, thinking about the machines that I used when I was in school, I'm hearing you say that, as far as like horsepower, they're comparative.
Yeah, we estimated that the processor in that watch was about the same as an old PCAT that we worked on when we were younger.
Wow.
And took up most of my desk.
That's amazing. Now, when you're trying to make the .NET framework and then the CLR work, how confident were you that it was going to fit? I mean, I think of the framework scaling up. I remember switching from 32-bit processors to 64-bit. I remember applications using 2, 3, and 4 gigabytes of RAM, scaling out, scaling up. How hard is it to scale down, and what kinds of things do you have to throw away?
It actually requires that you start from scratch. There's really no effective way that we've never found anything that we could take an implementation that didn't start thinking how small it could be and effectively scale it down. So what we do is we and it's one of the reasons why we're sort of an oddball in the .NET family. The other .NET versions, the compact framework and the full framework, are in sync and compatible. So if when you look at version 4.0 of compact framework, it'll be the same as 4.0 of the full framework. Our 4.0 is sort of an odd mix because we go up and look at what's going on in the main framework. We sort of cherry pick what's appropriate for these smaller devices. There's a lot of things that, frankly, are not as useful, not likely to be useful on these small devices, and then we re-implement what's important down there. So we spent, because these are connected devices, we spend a lot of time picking things out of WCF, and so we have support for web services for devices, or DPWS. Because these devices frequently have user interfaces, we took a lot of the WPF model and put that down here. But again, all these things are uniquely implemented for these devices.
The development environment is Visual Studio, and I was actually surprised/impressed when I just installed .NET Framework, Micro Framework rather, 4.1. I said file new project inside of the same IDE that I was using for websites, that I was using for Windows Phone. It's all inside there. So that was cool. And then F5 debugging, all that stuff worked exactly as before. Now I noticed that I did have to install something special for each board that I had. I have a GHI electronics board, I have a Tahoe 2 board, and a Netduino. So 3 different boards from 3 different manufacturers. They all use the micro framework, but for each of them I had to install something else. Can you talk about the relationship between the micro framework and that thing that I have to install for each board?
Yeah, there's essentially 2 layers of work that our partners do. The application that you create is hopefully going to be very hardware independent because you're working in a virtual machine, which is our CLR. And underneath that, because the processors and the hardware that each of these partners is using is fundamentally different in some way or another, there's a requirement that they actually work at the driver level. That's done in C++ with the tools that are provided by the processor manufacturer that they select. So they do some of the heavy lifting to glue the micro framework into their specific hardware. And then at the upper level, another thing that you're going to find is that they extend the micro framework. So they'll have libraries that run on the micro framework, on the CLR, that provide things like additional drivers for CAN bus, for Wi-Fi, for a variety of other sorts of functionality that aren't supported natively in the micro framework. One of the things that this model does is that it actually enables, because we give you access inside the micro framework to the underlying hardware, you can actually write your drivers in managed code and have it run on top as well as writing at the bottom layer.
Yeah, that's interesting that you point that out, because I think it was the Tahoe 2 that I was looking at that had an accelerometer, and the code that I was reading for that actually referred to the name of the chip, so it was like namespace dot, whatever the name of that particular chip was, and it was written entirely in C#. So I was wondering, is it really a driver, or is it just a layer of abstraction? Or I guess is that the same thing?
Well, by functional definition, it becomes a driver. You could do that same thing in C at the bottom layer, but whether or not you do need to do that as opposed to using C# largely depends on what your performance requirements are. Obviously, there's a significant difference between running interpreted code and running native code.
Is this code JITted? I mean, is it interpreted the whole time, or what kind of performance can you expect to see with C# on these devices?
It's all interpreted. One of the things, so to give you an idea of what our footprint target is, we actually will run on a machine with about 64K of RAM, which was one of our targets, and 256K of flash. And when we were doing that, as you get down to those sizes, JIT doesn't really work very well because there's a couple things. One is that native code is about 10 times larger than IL. So right off the bat, as soon as you JIT something, it becomes larger. And the other thing is that when you're close to the edges of your memory availability, what we'd found is that you would start thrashing. You would JIT something, it would call into something else. You'd throw away what you just JITted so that you could JIT the other thing. And then when that returns, you have to re-JIT what you just threw away. And so there was a very steep performance cliff when we looked at JITting. In terms of performance, it really depends on the application. It works fine for UI. It works. I've used it in a number of applications that where it can be very responsive. One of the things in terms of when people talk about real time, one of the things that they insist on is having deterministic response, so that if I hit a button, I know every time I'm going to get some specific latency. We don't have that right now because we have a garbage collection cycle that may hit at some undetermined time. So that's one thing that if we were going to try and address more real-time applications, we would have to address. And we've discussed some strategies for that, but it hasn't quite made it up to the top of our priority queue yet.
This is the part of the show where I mock you. Well, actually, Telerik mocks us. Your applications that you're testing dependent on external systems over which you have no control. Maybe you're being slowed down by those systems, their lack of availability, responsiveness. You want to do TDD right. Our friends at Telerik help you solve some of those problems with their newest mocking tool, Just Mock. It'll let you do fast, simple, controlled unit tests independent of external resources like databases, web services, proprietary code. Unlike some mocking tools, Just Mock works with non-virtual methods, sealed classes, static methods, giving you complete control of your code. You can get more details. You can download Just Mock at Telerik.com/JustMock. And don't forget to thank Telerik for supporting Hansel Minutes on their Facebook fan page, Facebook.com/Telerik. Thanks a lot. I took the Netduino, which was a device that I wanted to play with it immediately, and I didn't have any hardware yet to speak of. So the only thing I could really do was blink the LED on the Netduino, because it's the smallest of the devices that I have. But I wrote in, 60 lines of code, a little Morse code application. So it would take ASCII and it would spit it out as Morse code. And other than one line where I talked to an output port object, and I referred to the onboard LED as a constant, everything else looks exactly like, you couldn't look at it and tell it wasn't a console app. So I thought that was pretty impressive. But because I was on such a tiny device, I will say that I was a little paralyzed from a programmer's perspective, because I was paranoid that I was going to write something that wasn't performant. And I went back and forth. Should I use a hash table? Should I have a bunch of constants? Should I use parallel arrays? How worried should I be about that kind of thing? And is that a natural feeling to be so concerned that now I'm in a tiny world, I should write my code differently?
Unless you're, I think unless you're in the range of trying to do like voice processing, for the kinds of applications that certainly any of the hobbyist applications, I don't think you'll run into many times when you have to worry about performance at all. There are some tricks, I think, to and there are tricks to, if you were writing a commercial application that had to run on batteries. Then you want to make sure that, for instance, that you run everything on events so that the processor can, because the processor will, the thread manager, when it can't find a thread to run, will automatically go into a lower power state. As long as that's supported by that processor. So you have some programming tricks like that for commercial applications where you might have power constraints. But for most any of the hobbyist sorts of applications, I have never run into a performance problem.
That's interesting.
And then the whole thing's open source, so if you ever do have any real performance problems, and you want to solve them by going into native code, we both have the source out there, and we support interop. So one of the nice things, I think, about the model as it's currently set up is that you can get into one of these devices at a very high level. If you really want to get roll your sleeves up and get into it, you can take it as far as you want in terms of diving into doing, like I said, native code, or even going into the bowels of the micro framework or the porting layer and redoing what you want to.
So it's all open source. It's all, what is it, Apache license all the way down?
Right. Everything. Apache 2.
Wow. Was that hard to get Microsoft to do that?
It's hard in parts, but I think that there's certainly an appreciation for that model that's growing in the company. There's a lot more support for that than I think there was in the past. And there's a lot more things you're seeing, like Iron Ruby and Iron Python and things like that are joining that trend. We actually took a couple of years where we tried to make a commercial business out of this and charge a per unit royalty for the micro framework. But the reality struck us that there just really isn't enough money in that. And when you're talking about a $2 processor and a $10 device in terms of its bill of materials, it's really hard to squeeze a couple of dollars or anything meaningful out of that. So this is a much better approach for this size device, I think.
What does Microsoft get out of it? I mean, don't you worry that if it's not a big business, that your whole group will go away someday?
Well, it's not a big business from a Microsoft standpoint. I think it's an important business for Microsoft because, like I said, these devices are now connected. Microsoft is absolutely unique in this arena because we have a single programming model and tool chain that'll take you from the Netduino board up to your PC, up to web pages, up to servers, and up eventually to the cloud. So the same programming skills translate through all of that. I think that's an important story for Microsoft. And I'll be quite honest, if other platforms are used at the bottom end, nobody wants to have a mixed development shop if they don't have to. So I think it's useful from Microsoft's standpoint for us to be able to say that we have this single programming model that has the broadest range of any.
How many people do you have like actively writing code on this inside Microsoft? How many like Microsoft employees work on this thing?
There's 4 of us.
See, that's amazing that you pulled that off. I'm sure that many people worked on it over the years, but the fact that there's 4 now is pretty amazing. And how does the open source stuff change the way that that the partners interact? Like I assume Netduino, one day they called you, like when I assume it just came out of blue, right? One day the phone rang, hey, I want to do this, or can he do all of it by himself without ever giving you a call?
He actually showed up one day and said, "Look what I got working." And
really?
So yeah, he could do. You can do this all by yourself. We try and help people as much as possible. Yeah, but obviously with 4 people, we do rely on the community to be self-sustaining and to some extent, and we have some participants in the community who have been just great at pitching in and helping each other out. And we've actually, so we went to open source with 4.0 last November. We did our 4.1 release just 6 months later to get Visual Studio support and a couple other things in there. And we already, within that time frame, had our first contributions from the community that were included in that release. And we're hoping that continues to grow, frankly.
That's cool. And so there's committed code from people who aren't you inside of 4.1.
Absolutely.
That's cool. So I brought up the Netduino one because it's the smallest one I have. Are there smaller boards, or is that pretty much the smallest as far as like the limited amount of functionality?
I think there are 2 companies that are making boards in that size. GHI Electronics and as a board on their TinyCLR site, and the Netduino board. They're both Arduino compatible boards. Arduino is a very popular hobbyist and education board, and so there's a lot of peripherals for that. I just blogged recently about putting an Arduino shield, and the hardware is frequently called shields for the Arduino, a joystick shield on top of a Netduino, and running a robotic arm with that. So they take advantage. Both those companies take advantage of the fact that there is an existing ecosystem of hardware packages for the Arduino board.
Yesterday, this is a true story. Yesterday, I was cleaning up my office, and I've seen your office, by the way, and I know that if either you or I clean our offices out, it's going to be an event, and it's going to uncover some amazing pieces of artifacts and pieces out of the past. So I'm digging through my office, and I found a Newton message pad, and I found, computers that were 20 plus years old. And I found this thing called a Space Orb 360. This is a 3-dimensional controller. It's basically a rubber ball posted on a stick. And instead of using your thumbs and two joysticks, you just push this ball up, down, left, right. And it is to this day still used as a 360-degree 3D modeling tool. But in the early 90s, it was used on games like Descent and Doom to do 360-degree stuff, but it only works on a 9-pin RS-232 serial, and the company's basically given up on the gaming world. And to the hardcore gamer, this is the thing, right? Over the years, I've been looking around trying to figure out if I'm ever going to bring this thing back to life. And last night, I start poking around, and I find a guy who made an orb shield. And you just said that an Arduino shield is a board. It's a daughter board, effectively, for one of these compatible devices. And because it's a standardized platform, and there's some work that's been done to make it show up inside of Windows, this guy has basically, you pay $30 or $40, you buy this Arduino shield, and he has that bridge that makes this 20-year-old joystick look like a joystick in Windows 7. So I'm really looking forward to playing with that and seeing what I can do maybe moving things around and writing an Arduino port, a .NET port in the .NET Micro Framework to see if I can take input from this thing. And that just in the 3 days that I've been playing with this is already kind of what's opened up for me.
Yeah.
Which is amazing.
Well, yeah, so I think one of the interesting things is that I think everybody who went through engineering school, either computer science or electrical engineering, remembers some of the great fun they had making things work. And everybody has a story, and that's one of the things I think that sort of excites people about this is being able to get back to just being able to make things happen. A lot of times we get into our jobs and they're a little more abstract than making an LED blink. So
yeah, it's funny when I got the LED to blink, and literally I think I put an hour into this. It's so silly. There's just this little internal child that was just like woohoo, even though it was such a basic thing. So then I started poking around with the larger boards. Talk to me about how these boards scale up physically. Because like we said, we've got the Arduino and the tinyclr.com from GHI. And then on the higher end, they've got touch screens and they've got accelerometers and buttons. Yeah,
so there's a full range of boards right up to some very expensive, very serious commercial boards. Essentially all of our ports that have been done by the silicon providers. So usually they have, for each of their processors, they have either they or some partners provide development boards. And then folks like OG in Europe, Device Solutions, .NET Solutions in England are all providing additional boards that go right up to, like you say, touchscreens and full exposure of some very powerful processors. By that time, you're looking at usually an ARM9 in the hundreds of megahertz processing power. Another project I did recently on the blog was to actually create a bicycle computer.
Mm-hmm.
And it's the idea behind it was that I'm always saying that now anybody with .NET skills can create an embedded application. So I thought, well, maybe I should do it to show a sort of a demonstration. So defined what I thought would be a reasonable commercial application. A few bells and whistles. It's got a gesture interface, partly because I didn't want to be fumbling for buttons at 40 miles an hour downhill. And there's going to be an article on it coming out in an MSDN magazine I think next month, talking about how you can now take that and connect that up to the cloud. So now when you get your bicycle into the garage, you just tap the screen and off goes the data to some service that lets you either compete or with your friends or collect your data. But that was written on a sort of intermediate board from GHI. So there's a board for almost any application.
Now, this is a 9-part series that you did on the bicycle computers on the .NET Micro Framework blog, and I'll post all the links in the show notes to make sure. And this is a really great tutorial because you went through it really step by step. Was this about the way that you thought about it? I mean, you started with picking the board and then deciding on the sensors and integrating the touch and then adding more complicated sensors. Is the way you wrote it the way that you built it?
It was absolutely stream of consciousness. In fact, I had thought I would do 3 articles and got just took it where it would lead me. I actually have 3 more articles in draft form that I haven't had time to finish that I hope to get back to at some point because the project keeps evolving.
And this is something that all the full source code is available, and it's up on Codeplex. You used a GHI Cobra board.
Right.
Did you have to custom build anything, or was this all stuff people could, brackets and things that we could find at Home Depot?
The stuff, most of the things that I bought, I got out of places like SparkFun, and I identified the particular boards that I used. There were things like accelerometers and pressure sensors. There was some back and forth. I was trying to use a pressure sensor to tell what my altitude was, and I ended up using an inclinometer instead. Nice. I went through, why I ended up with that. It was certainly easier to deal with than the pressure sensor, which seemed to be a little odd.
Mm-hmm.
But yeah, all that stuff is available. There is some soldering involved.
Sure.
To that point, and I'll give you a sort of a sneak preview. We're going to announce something at Maker Faire in New York later this month that is a little bit of a breakthrough on making this kind of project available to people who don't have electronic skills.
Oh yeah.
Yeah. So
what am I
think
going to want to watch for that? You're not going to drop the scoop right here, are you?
I better not. I'd get in trouble for. It's actually a project coming out of MSR in Cambridge, Microsoft Research in Cambridge, and so it's really their scoop to drop. But later this month we will be talking about some really cool stuff. To the point of your recent blog, where hardware for software engineers. This makes it possible for anybody without anybody who can program to do some really fun stuff really quickly.
Very cool. Very cool.
It was technology that Microsoft Research did specifically so that they could prototype devices quickly. But it makes it easy for anybody to do things now.
All right. Well, we'll look for that at Maker Faire. And I'd love to see, when you finish your series on the bicycle computer, I'd love to see a YouTube video of the whole thing in action.
Yes, I'm going to do that. I was thinking about doing that hopefully before the summer's completely gone.
Yeah,
it's already raining up here.
Yeah, it's raining down here too. It's the beginning of September, but we've already decided here in the Northwest that November has arrived.
Yes.
All right. Well, thank you so much, Colin Miller, for talking to us about the .NET Micro Framework. And this has been another episode of Hansel Minutes. I'll see you again next week.